If the quadratic equation ax square minus bx plus 12 is equal to 0, where a and b are positive integers not exceeding 10, has roots greater than 2, the number of possible ordered pairs a comma b is. This is a numerical type. Let us consider the given quadratic equation ax square minus bx plus 12 is equal to 0. Both the roots have to be greater than 2. Let us divide the equation by a and consider the equation f of x is equal to x square minus b by a into x plus 12 by a is equal to 0. This equation has to have roots greater than 2. The first condition is the roots have to be real. So discriminant greater than or equal to 0. Minus b by a the whole square minus 48 by a greater than or equal to 0. We can multiply the equation by a square. A is positive. So we get first condition b square minus 48a greater than or equal to 0. The second condition is f of 2 should be greater than 0. Substitute, we get the condition 2a minus b plus 6 greater than 0. The third condition is sum of the root should be greater than 4. That is b by a greater than 4. A is a positive integer. So we can multiply both sides by a. Inequality remains the same. B greater than 4a. We need to find out positive integer values of a less than or equal to 10. And positive integer values for b less than or equal to 10, which satisfies all the three inequalities. Let us consider the second condition. We get 2a plus 6 greater than b, but from third condition we know b is greater than 4a. So combining both the conditions, we get 2a plus 6 greater than b, b greater than 4a. That gives us an inequality 2a less than 6. That is, a is less than 3. We know a is a positive integer. So the possible values for a are 1 and 2. First, let us consider a is equal to 1. So when we put a is equal to 1 in condition number 1, we get b square minus 48 greater than or equal to 0. That means the minimum value of b has to be 7. So a is equal to 1, b is equal to 7. Substitute in condition number 2. We get 2 minus 7 plus 6, which is 1, 1 greater than 0. So both the conditions are satisfied for a is equal to 1 and b is equal to 7. The other values of b that we can consider is b is equal to 8. B is equal to 8 satisfies condition 3 as well as condition 1. But when we substitute a is equal to 1 and b is equal to 8 in condition number 2, it becomes, left hand side becomes 0. 0 greater than 0 is not satisfied. Similarly, any higher value of b, namely b is equal to 9, b is equal to 10, though they satisfy 1 and 3, will not satisfy 2. So there is only one acceptable value for a and b. A is equal to 1 and b is equal to 7. Consider the second case, a is equal to 2. Substitute in inequality 3, we get b greater than 8. But when we substitute a is equal to 2 in condition number 1, we get b square minus 96 should be greater than or equal to 0. So the value for b is only 10. But when we substitute b is equal to 10 and a is equal to 2 in condition number 2, we get left hand side to be 0. 0 greater than 0 is not possible. Therefore, b is equal to 10 is also not acceptable. And the condition says both a and b should be positive integers less than or equal to 10. So there exists only one acceptable value ordered pair a comma b, namely a takes a value 1 and b takes a value 7.